Hello and welcome to Mechanical Y. Here I have a flame, and today we're going to discuss an interesting property of fire. That is, fire is an electrical conductor. You can pass an electric current through fire with very little electrical resistance. In other words, fire has a relatively low electrical resistivity. Let's see if we can demonstrate this property by measuring a flame's electrical resistance directly. Here I have a multimeter set to measure resistance. The two probes of the multimeter are connected to these wires, so they are reading the resistance between these two tips. As you can see in air, the resistance is reading an error, meaning that the resistance is too high to measure, showing that air is a good electric insulator. When I touch the leads to a piece of aluminum, the resistance drops to pretty much zero, showing that aluminum is a good electrical conductor. An electric current is a flow of electrons. Room temperature air does not allow electrons to flow very easily through it, so it has a high resistance, making it an insulator. Aluminum, on the other hand, allows electrons to pass through it much more easily, giving it a low resistance, making it a good conductor. So here I have a small butane torch that will give us a nice controllable flame. Now if I light the torch and place the two leads of this probe into the flame, we see that the resistance goes down very noticeably. This means that the flame is conducting electricity much better than air, albeit not as well as the aluminum. Electrons are being allowed to move through the flame relatively easily. So why does fire conduct electricity? Fire occurs when there is a large release of thermal energy. This is done by oxidizing or combusting a fuel, like the wax in this candle, with an oxidizer, which is found in the air around it. This release of energy excites the molecules in the area near the combustion. That causes the formation of ions. That is, the release of energy causes electrons to be freed temporarily from their respective atoms and molecules. When enough of these ions are created, we get what is called a plasma, where the electrons are allowed to travel more freely. This means that they can conduct electricity and carry a current. Simply put, hot gases allow movement of electrons, making fire a conductor. So why is this property useful? One key use of this property is detecting whether we have the presence of a flame. Let's say we have a burner or a flame hidden somewhere in a device that is very difficult to access, something like a jet engine or a boiler. And now we want to know when that fire goes out so we can relight it immediately. There are many ways we can detect the presence of a flame, but by measuring the resistance between two relatively cheap and simple leads, where the flame is supposed to be, I can immediately know if there is fire or not. And leads like this are robust, durable, and easy to produce, meaning that such a system can be very easily and cheaply implemented. Thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, please visit us at www.mechanical-y.com.